let's talk about some properties in math. And these are going to probably sound pretty basic and self-explanatory, and you probably already are familiar with them and do them without even thinking, but they have names. So it doesn't hurt to put labels on things and just do a quick review on some basic foundational things. So we'll start with the commutative property, and it applies to two operations, so addition and multiplication, and we'll look at both. So the commutative property for addition says this. If we are, or we'll say, when adding any number of terms, you can order the terms in any way. So for example, if I have, if I'm adding two numbers, we'll call them A and B. They can be any numbers, so A plus B. Well, if I just change the order, and I instead say B plus A, I'm going to get the same answer. So let's use some actual numbers and just prove that. If I did 5 plus 2, and then did 2 plus 5, well, for both of them, I'm going to get 7. So the order doesn't matter. I could also do more than one term. Let's say we could do A plus B plus C. Well, that's the same thing as saying C plus B plus A, or even B plus C plus A. Want to throw some numbers in there? Cool. Let's make, let's do 2 plus negative 3 plus 1. And if I were to rearrange that kind of like we did up here, well, that would be 1 plus negative 3 plus 2. And then if I arrange them in that order, that's going to be, let's see, negative 3. Yeah, negative 3 plus 1 plus 2. So over here, 2 plus negative 3 is negative 1, and then plus 1 is 0, so I'll get 0. 1 plus negative 3 is going to be negative 2, and then plus 2 is also going to be 0, so that looks good so far. And then negative 3 plus 1 is negative 2, and then plus 2 is 0. So we can see that the order in which we add things, whether we have positives or negatives, as long as we're adding, it doesn't matter the order that we put them in. So that's the commutative property of addition. We have a commutative property of multiplication as well. So when it comes to multiplication, the same logic applies. So when multiplying any number of terms, you can put them in any order. So again, kind of like how we had A plus B, let's do A times B. Well, if I do B times A, I'll get the same thing. Plug in some numbers to prove it to yourself. If you did 3 times 4, and then on the other side did 4 times 3, well, we're getting 12 in both cases. Add another term. Let's say we did A times B times C. And remember, you don't need to write that little dot in between our variables here. If you don't write anything in between them and just sandwich them next to each other like that, it's understood that means multiplication. So A times B times C, that's the same thing as C times B times A, which is the same thing as B times A times C, which is the same thing as A times C times B. You can do all the combinations. I think there's 8 there. And then if we plug in some numbers, let's do 2 times 10 times 3. And if I arrange it C times B times A in this way, that's just backwards, so that'll be 3 times 10 times 2. BAC is going to be 10 times 3 times 2. And then A times C times B is going to be 2 times 3 times 10. So over here, 2 times 10 is 20, times 3 is 60. Here, 3 times 10 is 30, times 2 is 60 as well. Looks good. Here we got 10 times 3, which is 30, times 2 is 60. And then lastly, 2 times 3 is 6, times 10 is 60. So we get the same answer for all 4 ways of rearranging those terms. So here you have the commutative property of addition and multiplication. If you're doing addition, doesn't matter the order that you add all the terms. If you're doing multiplication, it doesn't matter the order that you multiply all the terms.